So I have Phil and Jamie, who are from Instinctive and GemSurf. So if I can introduce yourselves, or you introduce yourselves, and we'll take it from there. Thank you very much.
I'm going to cut in actually on this one again. So,
I'll bring you, Jamie.
yeah, no problem. Okay, doke. So, contrary to what you might have heard, I'm sadly not Phil or Jamie, but they will be introducing themselves in a few moments. In contrast, my name's Ross Melton. I come from Instinctive Partners, which is a political consultancy that's been supporting JRC for the last couple of months. Now, where I come into the equation, I met Peter and Julian about sort of 10 months ago, mid-lockdown. I'm very pleased to see that this is my first time actually meeting them, and I'm really pleased to see that they actually aren't just disembodied torsos and heads, but have legs as well. But during that initial discussion, they were very clear with us and my colleagues at Instinctive Partners that the engineering argument behind allocating radio spectrum access for the energy networks industry is clear. But the understanding and awareness within political and regulatory stakeholders was limited, and that was preventing what's self-evident to a lot of the people in this room from actually getting implemented in practice. So my role and Instinctive's role is to translate that expertise that you already have within the industry, that understanding of why radio spectrum access is required, and turning that into something that's politically salient, dovetailing it into current government policy so that it works with the grain of what the government wants to achieve, particularly around buzzwords that we're all familiar with, like levelling up, like regional growth, and of course decarbonisation policy. So we were taken on in May very specifically to achieve this objective. So the words that I would add to this objective are creating political awareness, understanding, and then support. And if you think of those as on a bit of a slope, if you haven't heard of something, if you're not aware of it, there's no way you're going to be interested in supporting it or implementing it in practice. So we're moving political stakeholders along that line from at the bottom of the hill, low awareness, low understanding, moving them into understanding and then into active support. So how have we gone about that? As you'll see there, we've got 3 stages to the campaign that we've been doing over the last 9 months. First is very much around developing your argumentation and messaging to achieve radio spectrum access, and I'm looking forward to handing over to Phil and Jamie to take you through some of the harder sort of economic analysis and evidence base. And then identifying those key targets. So who are the people who are the active decision makers within Westminster and Whitehall who are going to be able to make this happen? Second is going out and actually engaging with those people directly, which we can look at a little bit more in depth in a moment. And third is the one that I'm always most interested in. We can go out and we can speak to people all day, but if they're not actually doing something to implement what we're calling for, then it's pointless. So mobilization is always a key one for me and something that we can talk about a little bit later. Ooh. There we go. So over the last 9 months, we have been fairly busy. We've been making a number of approaches to your relevant stakeholders. So first, at top of the list is always going to be ministers. Some interesting names there, but of course, we've had a reshuffle halfway through the 9 months, so we're having to not restart, but reignite some of those engagements. So, of course, Trevelyan's been moved on and replaced by Greg Hands, who's, believe it or not, my constituency MP, so I've got a little bit of it in there. And then Matt Warman's been replaced by a lady called Julia Lopez, who is relatively new to particularly digital infrastructure, but we'll get there. We'll help her to understand. Second tier is moving around the people who are very influential within this policy sphere. So select committees are subgroups of backbench MPs who have become specialists in a particular area. And these are the 3 committees that are really influential in this space. I'm going to start with DCMS, who are, of course, the policy holders for radio spectrum access. We actually had I was actually spent the day with Julian Knight only a week ago in Coventry, and was able to take the opportunity to advocate on behalf of JRC and increase his understanding. Darren Jones over in Bristol, BEIS, of course, being the natural sort of home for discussions around energy infrastructure, another key stakeholder, and science and technology is sort of tangentially influential, particularly because Greg Clark is a former Conservative minister himself and remains an influential voice. Outside of that, we've been pushing for shadow ministers who are also very influential there. So we've got two pictures up there of JOIN01, who I know Julian will be meeting with on Tuesday next week to really reiterate some of our messages. And then on the left there, we've got Dr. Alan Whitehead, who is the man who's written the book on UK energy policy from a political point of view. And we spent a bit of time with him at Labour conference, as well as a couple of other opportunities. Besides that, the other picture that you've got there is Laura Sandy. So for those of you that are unaware, she's a former Conservative MP for, I believe, very east part of Kent. But she remains an extremely influential figure within government and enjoys the ear of Kwasi Kwarteng, the energy secretary in particular, specifically around energy digitalisation and flexibility. So it's a natural ally of our own. We've spent a bit of time with Laura and the Energy Systems Catapult, bringing up their understanding of why radio spectrum access is essential for the industry. Besides that, we've also spent a huge amount of time within Whitehall. So we've been talking about Westminster, now we're in Whitehall, and looking at officials in particular. We've actually met with officials in BEIS and within DCMS more than 3 times, and we're actually sitting down with a large group of them on Monday to take them through GemServe's economic analysis. Now, as I intimated at the beginning, meetings are all well and good, but they've got to end up with something. They've got to deliver something for the industry. It's not just talk. And I'm pleased that some of our other speakers have already indicated what some of the key outputs have been. You know, we can't take all of the credit for this, but our political engagement has helped to guide colleagues like Raj to commission new research and investigations into radio spectrum access from DCMS side of things. We've seen a similar review being commissioned from BEIS, and of course Gopal earlier was telling us about the Ofgem internal review. All we've got now is to just get Ofcom, and then I feel that we're going to be at a full house of getting those key political stakeholders to get on board. I'm now going to pass over to my colleagues Philip and Jamie, who are going to take you through the economic analysis. As I say, the key motivator here was we're going out and meeting with political stakeholders, but we've got to have something compelling to say to them. We've got to have some evidence that translates the engineering and technical discussion that we can have here into something that they will understand as political animals. And that's where economics really comes in.
Hello everyone. And thank you very much, Ross, and to everyone else for inviting us today. I'm Philip Twiddy, and I work for GemServe, a medium-sized professional services company. Our background is in the energy sector, but more recently in cyber and digital as well, low carbon, and within low carbon, small but specialist and capable economics function. And latter part of the summer, we were asked, or we tendered for and won the opportunity to undertake the economic analysis to set out what is the case for spectrum access for a smart grid, and to demonstrate out of the various ways of delivering a smart grid what is the most economic way of delivering that requirement. So our approach was to go back to published and reputable sources of information, and we've listed some of those on the left-hand side here. And that helped us to put together some of the benefits case for why do we get benefits from having a smart grid, and the cost stack for delivering that capability. So we've interviewed many distribution businesses, electricity and gas. They've been extremely helpful in helping us to understand what benefits can be achieved, whether those benefits are available through all of the different technologies that could be employed to deliver a smart grid, and also to understand some of the business cases. So, for instance, your business helped us with some information from the Rio submissions to understand what are the cost bases for implementing the infrastructure. So all of the distribution businesses, gas and gas transportation and electricity distribution businesses, been extremely helpful. We've used other reliable and published sources of information that help us to understand how flexibility can reduce network reinforcement, reduce or avoid some of the new generation capacity that might be required, etc. We've then used our expertise and knowledge of the energy industry and some of the relationships that we have to filter and identify those sources of information and make sure that we're using them appropriately. So there's a plethora of information that's out there, and so we've used those skills and knowledge to make sure that we're using it correctly. As I mentioned, we have this economics capability. They have a modelling approach, and we've developed the model to help us to set out what is essentially the net present value of building out the operational technology using the different methods. And then out of that, we've developed the results, and we've looped back round to the people that have helped us to make sure that those results are sensible. So that's our approach. It's very much reliant on information that is out there already. Our report will be made available, and we cite those sources and how we've used them. So it's about piecing together the information that's already available into a jigsaw that's appropriate for what we're trying to achieve. So this is the cost-benefit case for a smart grid using operational communications based on a private RF spectrum. And the two big candidates here are avoided network reinforcement, and primarily that comes from better understanding of what is happening on each of the networks at a very granular level. So understanding things like the dynamic load ratings, what's happening thermally, what's happening on the voltage, and being able to plan better because you've got better insight at what's happening on the network. Maybe being able to defer investment because what you thought was at capacity isn't at capacity. Being able to use what you can see to use flexibility to, again, shift some of the peaks and use that to avoid that network reinforcement. Closely related to that is being able to avoid some of the generation capacity that would otherwise be needed. So if you can see where those peaks are and if you can manage those peaks, then you can avoid or you can use distributed energy resources more intelligently, and you can avoid some of the generation. So we've used, as a baseline, we've used information such as what is published by the CCC on what they're predicting as the baseline for generation capacity out to 2050, and looking at other sources about how that could be reduced by using that flexibility. We see significant savings from reduced outages. So again, coming back to better visibility of what's happening on the network, so you can plan and target those network improvements, so you avoid having the network outages, and then having better information about what's happening. So active or visibility of potential issues as they're about to arise, so you can deal with them before they become issues. Having information about warnings and alerts that are coming up, having active network management, and being able to protect the network and then automatically recover those outages. So we've used information as published by Ofgem, for instance, about the customer minutes lost and customer interruptions, and distribution business cases on what they have achieved so far with the networks of the smart grids, to the extent that they put them in so far, and the benefits they've already seen, and what they're predicting from further improvements. And reduce black start costs. So this is coming directly from the National Grid ESO. So they have a business case, they're working on a project for black start, and so most of those benefits come from being able to use distributed energy resources, having more of them than you have for the thermal assets, so you have more competition, and you don't have as many payments, such as kind of keeping thermal generation warm so that it can respond in the necessary timeframes. And then we've looked at the cost stack as well, and what we see here is the bigger one here, less than £1 billion, is for the communications infrastructure for building out an RF-based operational communications system. And then a couple of insignificant, when we're looking at this particular communications capability, so a flexibility platform that's small regardless of the communications that you're using. And we've got a small estimate for, or a small inclusion for backup power for RF spectrum. So the vast majority of this infrastructure would be on distribution businesses, real estate, and that has backup power. What we see in others is, Jamie will talk about that. So what we see is a significant net present value. So for a roughly £1 billion investment, we should be able to achieve a net present value of £12 billion. So it's a good investment. There was a question earlier about how can we afford it. So I can't answer that in terms of how can we afford all of the electric vehicles or all of the heating systems that will be replacing the high carbon with lower carbon alternatives. But if we assume that we are in a world where we will have those things, I'd almost ask that question, how could we not afford it? Because what we see is a relatively, how can I really say £1 billion is small, but a relatively small outlay for a far greater saving. So if we're going to have this world of low carbon, then we need this world, because it's going to reduce, for instance, the amount of network reinforcement that would otherwise be required. It's a significant saving. So Jamie, I think over to you. So
great. Thank you, Phil. And yeah, great to be here today talking to you about radio spectrum. So as we've seen, there's a strong economic case for smart grids. But I think what's not shown there is the need for a private radio solution. So yeah, as part of our analysis, we considered 3 options, which were private radio, using commercial mobile networks, and using fibre networks. We haven't shown fibre on this graph because the costs were just astronomical. So they were over £50 billion, and that's even when utilising lots of the public fibre already there, so using BT's Openreach network, and just topping that up with a private fibre network where necessary. Our analysis has found that the private radio solution would come in at roughly half the cost on a net present cost basis than using commercial mobile networks. So it's by far the cheaper option. And there's a few reasons for this in our analysis. So the first of these being that there is a rip and replace nature of commercial mobile networks, and we've assumed that the infrastructure would need to be replaced 3 times in the period up to 2050. Whereas with a private radio solution, you would just have a single infrastructure rollout, and we've assumed a lifetime of greater than 30 years for this. The next reason why we think a commercial mobile network is going to be more expensive is the data charges that you pay each year. And finally, the need for backup power at 15,000 macro sites is what we estimate would be needed to make a commercial mobile network power resilient. And as we can see there, that's a significant cost of £400 million on a net present cost basis. So aside from this cost saving of using a private radio network, there's also significant risks with using a commercial mobile network that have not been included in this cost analysis. And these include commercial mobile networks not offering guaranteed standards of performance and the power resilience. So this estimate of power resilience is just a pure cost, whereas we think there's probably going to be a premium if commercial mobile networks were to offer that. There's also cybersecurity concerns with using commercial mobile networks, which we obviously don't want on the electricity system. Another concern for us was the fact that backup power would only be provided by one of the mobile networks, which would create a monopoly, which would likely need to be regulated. This is likely to add higher costs, as the MNOs are likely to keen to avoid regulation. One final concern of using a commercial mobile network was that the coverage in rural locations just isn't there yet, and that's likely to add additional costs. So in conclusion, I think we've shown that there's a strong economic case for smart grids, and that a private radio solution is likely to be the most financially and technically appropriate solution to delivering these. Thank you.
Perfect. So you can imagine why we work closely with GemServe. You can imagine why, we're going out into Parliament, into Whitehall, securing opportunities for Peter and Julian to meet with key political stakeholders. But then GemServe are able to give us the ammunition to win those arguments, to be able to say, to immediately respond to the first question that we often get, which is, why don't you just partner with a commercial network? And many of the sort of technical and engineering-based arguments, which are, of course, very valid, are not always very palatable, shall we say, to lay people or political stakeholders who maybe don't understand them. But if we're able to say, well, actually it's because it's double the cost, that makes that conversation a lot simpler, a lot easier for those stakeholders to pass. So that's why we've been so pleased to partner up with GemServe, and why we're so pleased with the results that they've produced for us. Now, what are we actually going to do with them? How are we going to get those out there and start making an impact? So there's going to be a lot of activity in the next couple of weeks. The report is now finalised and scheduled to be published on the 29th of this month. There'll be sort of simultaneous media engagement that we'll be doing around it, just to build a bit of a head of steam behind it. GemServe and JRC will be releasing it simultaneously with their own media releases. We are preparing for that with a bit of targeted media engagement to help sort of roll the pitch in our favour. So I know Peter and Julian are sitting down with Utility Week in the next couple of days with exactly that hat on. We're also going to be aiming for some of the larger sort of broadsheets. The kind of papers and periodicals that influence people who are expert in this area. Besides that, we're also actively engaging with those officials again. We're hammering that message home. So I've already mentioned that Peter and Julian will be hosting with Raj, one of our previous speakers from DCMS, about a dozen officials on Monday to take them through the economic analysis in depth. And I know Philip and Jamie will be lending their support for that as well. We're also going to be sharing that directly with ministers, so it's on their desk. Now, I know that they're unlikely to read it in full, but if they're able to understand those kind of key salient points, it just means that the conversation that we have with them is going to be that much more advanced when we get in through the door. And then last thing to mention, we've We've talked about March 2022 as a bit of a date that's coming down the track at us. I know Raj highlighted it as the deadline for a lot of the responses to, or the department's response to its own consultation. We want to hit the ground running then as well with a policy roundtable that I will explain a little bit more in a moment. But again, the kind of key output from this is that the strong economic research that GemServe has provided us is able to get us to move some of those policy conversations forward again. So I've included this here because I'm never afraid to be kind of judged on our performance. These are the 7 outputs that we discussed with Peter and Julian 9 months ago. Pleased to see there's a couple in green, but there's a good number. The majority is still in yellow, so there's still a little bit further to go. We're still at that awareness part of the spectrum. We need to move forward into understanding and active support. How are we going to do that? I mean, if I had to summarize where we are at the moment, I'd say we've made some strong initial progress. Officials are increasingly aware of the energy network industry's requirements, partly from their own work, but also from our engagement and influence. The economic arguments that we're bringing to the table are helping to make ground and simplify the conversation down so it steps away from a technical and engineering conversation into one that's purely about government investment. But, and this is a big but, we need to get a political signal and a political indication of this is the direction of travel for the UK. We need a minister, we need a member of the government to say radio spectrum access is necessary for the industry. And that's what our focus needs to be over the next coming months, particularly as we push towards March 2022. I'd like to return, to conclude, I'd like to return to a kind of a metaphor that Ian actually gave us a little bit earlier about motor racing, that the industry is ready to ramp up, to move into those higher gears. But my job is to get you guys to the start line so that the government can fire the pistol, get you going, get you building. And I think we've made some serious progress, but I'm looking forward to doing a lot more. Thanks for the time. Oh yeah. Any questions? Of course.
Actually, I have a question.
Thanks, Bob.
So Bob Tyler, JRC. So thank you for an interesting presentation, Tim. And given, at the risk of flattery, so given obviously your shrewd operators in this political environment.
I'm blushing.
So once this report hits the press, if you were being paid a large amount of money by the mobile sector to defend their position and to undermine the report, what would you suggest?
It's a fair challenge, Bob, because the elephant in the room, and as we've alluded to several times today, is that the natural challenge that we get in political conversations is, isn't there a network that you can partner with already? Why aren't you just working with the commercial operators? If I was working for them, I would be suggesting we have incumbency. Why build something new when we've already got something? But that conceals all of the discussion and the arguments that we're all very familiar with here around the unsuitability of the mobile network to support the energy network industry. You know, before we even get to GemServe's economic arguments, it's the technical and engineering challenges that make them unsuitable. Their rip and replace cycle doesn't synergize with the same timescales that the energy networks industry works with. The lack of sort of basic power redundancy, as we've experienced from Tim's comments earlier, means that they don't fulfill the basic function of being able to support the energy network in a black start situation and being able to ramp up. So I think the commercial network operators have a strong card about saying we're here, just make use of what's already there. But we have working with Peter and Julian and JRC, developed some really strong counter-arguments that are beginning to make ground. And particularly with the support of GemServe, just being able to say that one little phrase of saying, it'll cost you double. That's all we need. And that can help simplify conversations right down to their constituent parts. I hope that helps well.
Yeah, no, thank you for that. And I guess to your point, actually, the rip and replace thing, you'd be selling that as free upgrades during the term of the network lifetime. Right? Yeah. Thank you.
Thanks, Ross. Really appreciate the presentation. I was just going to come back as an addendum to your response there, because I think, the other aspect that hasn't been considered or wasn't contemplated in response to that question is the extent to which the mobile operators actually want to play in this market, in this context. And we've seen from we've seen from behind the scenes interactions with the mobile operators that they have a tendency not to want to be liable for this level of resilience and redundancy. So, there's a presumption that they might be leaving something on the table here, but I think the harsh reality might be they'd actually be terrified of being required to do this. Just as an observation.
This is why I'm the translator, not the expert. I rely on Peter.
I think there's an interesting parallel to this, where you're talking about reliability and so on. I don't know how much people know about emergency services communications, but previously in the UK it used to be done over a dedicated network called Airwave, and then Airwave lost the tender to that to EE, who then promised to roll out a 99.9% geographic coverage network of the UK for the UK, with sufficiently high reliability and so on, and dedicated access to emergency services, including shutting off part of their network if it needed it. That is still not fully operational and is still working through. But obviously, it does indicate that at least one operator does have some, doesn't mind too much about having kind of very high reliability and coverage concerns. And of course, there might be then a bit of an overlap there, which they could rely on. But I think when I was listening to your modelling, there's an interesting question that kind of came to my mind about looking at it the other way, because there are parts of the country and geographic areas which are not covered by mobile at the moment. And they cite the reason for that is because it's too expensive to get the equipment there and so on. However, you are talking about actually wanting to get equipment to those places and high reliability and so on, which makes me wonder, have you thought about the possibility of selling them services? Within your economic modelling, one of the things you could do is to actually sell them access to your passive network for them to install active equipment on, or even, depending on what sort of equipment you're putting on, actually sell them kind of at a wholesale service. So I leave that as a possibility in the air.
There's lots of complications with regards to that concerning where leaves access on third-party sites, and do we want cellulars on our network, and whether they would reliability issues of us being in a contract with them. Our concern is for electricity supplies and not communications, their communications network, and that's our priority. So I don't think that sharing our network is the best idea in the world, really.
Okay, thanks for the presentation, Ross. So just to add to what Stuart said, and I'll come on to an online question that's just come in as well. Yeah, that idea about sharing utility infrastructure. We're aware of high-level discussions. The new electronic communications code resulting from work from the NIC and so on to mandate sharing of other infrastructure, whether that be rail or roads or even utilities, but it's not really moved very far, very fast yet for some of the obvious reasons that Stuart mentioned. And there's a similar initiative in the EU, actually, the Broadband Cost Reduction Directive, I think, but it'll be interesting to see how that develops over time. So the question online from one of our participants is, and it's quite a good question actually, isn't there a business case that multi-tenant industry licensees can gauge huge economies of scale, i.e. one CNI network which could be shared by gas, water and power? So Ross, I don't know if you want to comment on that.
As usual, I would bow to your sort of technical expertise on it, and we have been discussing around sharing infrastructure. I think we have to be wary of some of these conversations at this juncture, because the more that we discuss sort of sharing locations, sharing assets, the more we overlap into, well, why do you need something bespoke? Why do you need just something for your industry? So I'm a little bit wary of them at this stage. That's not to say that they shouldn't be reopened later down the track once we've won the argument, once we've got the infrastructure in the ground, once we've started it and got it operational. But for me, it feels a little bit early. Would others agree, disagree?
I would tend to agree, Ross. I mean, that was a remote question, but yeah, I would tend to agree. The more people we involve in this, the more players we've got to try and coordinate.
So many cooks.
Yeah, other parts that have been successful of the world on this, it's been led by electricity, and by all means, the other guys can come on later if that's an option later.
Aye, makes perfect sense.
Thanks.
Thanks for the. Oh, I think one more.
I wanted to ask the question on your economic modelling of what you've done, is where you stated in it infrastructure replacement of greater than 30 years. Now, on something like GSM-R, which is the railway network, is that technology is well past its sell-by date and it's costing them a fortune to maintain. Is the basis of thinking of technology which is going to carry on for 30 years, there's no change? 30 years is a long time. 30 years ago we may not have had the mobile phone. So has that been taken, how would you take that into account in your economic modelling? How it's very difficult to kind of come to terms with that, really. 30 years is a long time in technological advancements now. We'll probably be up to about 8G by then.
Conscious of time, and we have taken some questions down to be responded later. So let's take a comfort break.